Hey everyone, my name is Aryanna. I'm L1 team lead of Rutgers RPL. So today I'm going to show you how to SolidWorks your fins. Just keep in mind that you should have completed all of the Open Rocket stuff before coming to this video. So just make sure that you've done everything under Open Rocket. So what we're going to do today is we're going to look at your dimensions from your Open Rocket. We're going to create a new part in SolidWorks and then choose a plane to sketch on. And then what we're going to do is we're going to draw a 2D outline of your fin, starting at the origin, which I'll explain more about later. And then what we're going to do is smart dimension the outline. Again, I'll explain that later. And then we're going to extrude the fins or turn it into 3D instead of 2D. And then the last thing we're going to do is we're going to save that as a DXF file. So just to go through really quickly what a DXF file is. A DXF file is the format that we use at the makerspace to cut out your fins on the CNC. So the reason why we need that DXF file is because we can just kind of upload it to the CNC computer and then just tell the machine to cut out according to the DXF file. So that's why we need it converted into that file. Just to go through right now what SolidWorks is. So basically what SolidWorks is it's a 3D modeling software. We use it to sketch up things and then to either 3D print them or to just have nice blueprints of it. So basically, I guess the best way to explain SolidWorks would be like having blueprints on your computer that you can also 3D print and simulate with. So I should probably specify right now, there's probably a lot of you in L1 that have already used SolidWorks or something similar. Maybe you already know all the planes, maybe you know all the tools already. So what I'm going to do is right now on the screen and in the description, I'm going to put up the timestamps, which I'll obviously put up after I'm finished editing everything, as to where you can go if you've already used SolidWorks before, if you already know how to create lines. And you can just choose wherever you need to go. So if you forgot how to extrude, but you can do everything else, then I'll put all the timestamps there. And feel free to skip ahead once you get to this point. And of course, if you haven't used SolidWorks before, just stay and watch this whole video. So let's go through really quickly before we start going to SolidWorks the different type of planes. So we have 3 planes in SolidWorks, just like how we have 3 dimensions in real life. So if we were to think of the planes like a box, basically the top plane is going to be the top of the box, obviously. The right plane is going to be the side of the box. In this case, automatically it's put on the right side because, as you may remember from basic math, the positive x direction, that's going to the right. So that's why. And then the front plane, that's just looking at it face on. Like if I'm looking at my computer screen right now, that would be considered the front plane of that 3D screen. Okay, some basic commands. I'm gonna run through this entire PowerPoint first, and then I'll get to showing you how to do all of these things. Something you should keep in mind for SolidWorks is I'm actually not using one right now, but you should be using a mouse. You should be using a mouse for everything just because it's a lot more precise, it's a lot more accurate. You can use the touchpad on your laptop if you really feel like it. It's just going to be a lot harder to be accurate with it and things like that. So, if you also use a touchpad instead of a mouse, you're not going to be able to zoom in and zoom out very easily unless you have a touch screen on your laptop. So, just to go over the basic commands, if you want to select something just like normal, it's going to be a left click just like everything else. If you want to select a whole bunch of things, you're going to do a box selection, which is just taking your left click and then dragging it. If you want to zoom out, if you have a mouse, you're going to roll the wheel forward. If you want to zoom in, you're going to roll the wheel backwards. Something to keep in mind when you're zooming is that zooming is according to where your cursor is located. So if your cursor is located in the corner of the screen, it's going to zoom into the corner of the screen. If it's in the middle, it's going to zoom into the middle of the screen. So just keep in mind that your cursor matters when you zoom in and out. Okay, so the other thing you can do is you can rotate the camera or the view and orientation. You can just do that by clicking the wheel and then dragging. And this is something very common that happens in SolidWorks, but if you happen to get lost from zooming in too much, or maybe you've zoomed out so much that you can't find your part anymore, what you can do is you can hit Control 7, and that will take you right back to your sketch and center it for you. Or you can hit Control 8, but Control 7 is what's going to bring you back. Control 8 is what's going to bring you back to a specific plane view, which again, I'll cover that later. So the next thing that I want to go over is relations. So relations look like this. It has a green box and then two sort of lines in it. Sometimes it just has the one, like the first one. Basically what they are is they're almost like forcing something onto your lines. So what I mean by that is if I want a line to be horizontal, sometimes, so for example, like when you draw a line on a piece of paper, it might not be perfectly vertical, it might not be perfectly horizontal. But what SolidWorks does is it can automatically make it horizontal or vertical for you if you choose to do so. So basically, what relations do is they force a line to be horizontal. They can force a line to be vertical. They can force it to be perpendicular. Because sometimes what's going to happen is you're maybe going to want to draw a perpendicular set of lines. You want the angle to be 90 degrees. But maybe if you zoom in really, really far, it's actually not 90 degrees. Maybe it's 89.999, right? So if you want to make it exactly 90, relations are going to help you with that. So just to go over what these relations are, these are the 4 ones that we're going to use. The first one is going to be horizontal. It's just one line going across, and the vertical one looks the same. It's just going to be going up and down instead. The second one is perpendicular. So what you can do is you can take 2 lines, establish a perpendicular relation, and those lines will be automatically perpendicular from each other. The third one is parallel lines. So if you choose 2 lines and establish a parallel relation, then they're going to be automatically parallel from each other. And the last one, which you might not be as familiar with, is called coincident. So what that does is it forces 2 lines to meet each other. It forces them to collide. But you can also do it with a line and a point. So if you want a certain point to hit your line, you can establish a coincident relation there as well. So I'll go over this when I actually open SolidWorks and I show you things on there, but you need to be careful of overdefining things. That's super important because it's going to mess up your whole sketch if you do that, or if you underdefine things as well. So next we're going to go over what an extrude is. So an extrude is basically just taking a 2D shape and making it 3D. So I kind of put the steps here for you. So first you're going to make it 2D like this. And then I like to just basically turn it diagonal. That's called isometric view, but we'll get to that later. And then next you're going to hit the extrude option and it'll show you a preview in yellow. And then once you hit the check mark, then it'll make everything solid and it will give you your cube. So we'll go over doing that on SolidWorks itself later. The last really important thing that we have to go over is called a smart dimension. So if you've never taken a CAD class before, maybe you haven't seen this. So this is really important to establish. Basically, when you draw in SolidWorks, you're going to get blue lines. And what those blue lines mean is that you didn't tell SolidWorks how long you want it to be. It's just a line. It's like sketching something and not telling. Like when I sketch something on a piece of paper, I'm not going to say, well, this is 1 inch, this is 2 inches. So basically, a blue line is just going to indicate that we don't really care about the size now, we're just kind of sketching it out, we're doing a rough sketch. But what a smart dimension is going to do is it's going to tell SolidWorks, I need this line to be 1 inch, I need this line to be 2 inches. You're telling SolidWorks that this line has to be a certain length. Just keep in mind, we're not going to use this for our fins, but if you were to continue on using SolidWorks later on, especially if you're a mechanical or aerospace major, you can also do smart dimensions with things like angles. So you can tell SolidWorks, I need this angle to be 45 degrees or something like that. but we're really just going to use it for lengths. So after your smart dimension is established, like I said before, when you initially draw, it's going to be in blue lines, but once you smart dimension something, it's going to turn black, and you'll be able to extrude things, because if you leave the lines as blue, you're not going to be able to do anything with it. So really, the rule here is that you need to smart dimension anything. So I put that down here. When do I smart dimension? The answer is you always have to smart dimension. You can't just leave something undefined, or else you're going to be able to pull it around. It's not going to be fixed in place. SolidWorks isn't going to know how long you want it to be. So the answer is that you always have to smart dimension all of your lines, or else SolidWorks is going to just think that you don't care about how long the line is, and then it's going to get confused. You're not going to be able to extrude or anything like that. Okay, so right now I have SolidWorks open. Just keep in mind that I have the 2020 version downloaded on my laptop. I got this through RPL, but the thing is that we don't have infinite money, so we can't give SolidWorks licenses out to everyone. So if we can't give you a license, no offense, but most likely we can't if it's not the beginning of the year. What you're going to want to do is you're going to want to follow the instructions that I put in the L1 folder that gets you to VLab. So what VLab is it's the virtual computer lab here at Rutgers. It's basically like a legal version of hacking into the computer lab and hijacking one of the computers there. So you should follow the instructions to that. You can get the SolidWorks on there, on like the virtual lab. It's the 2018 version, so what you're seeing might be slightly different. Like I think, for example, it doesn't show shapes filled in the 2018 version, and on 2020 it does show closed shapes filled in, if I'm remembering correctly, but maybe not. I don't know. But basically, it's a little bit different, but 2018 version is going to be fine for you to use if you choose to use that. So basically, let's just go over the basic commands. So this was a workshop that I did for SolidWorks class, or CAD for mechanical engineering. This was like one of the first workshops I did. We ended up making a part like this. It's just basically a simple sketch and then an extrusion. So basically I'm just going to show you. So I have my mouse here. I'm just going to click on things, left click it, and that selects things. So I can either select a face, like how I'm doing now, or I can select an edge, like this. I can even select edges of these circles over here and things like that. If I want to select more than one thing, I can click on it, and then I can either hit Shift or Control. Keep in mind I'm on a Windows laptop right now, so I can hit Control or Shift, and then I can select multiple things. I can select multiple edges and a face, and if I don't want that face selected anymore, I can just hold Control again and select it, and it'll get rid of it. So I can also select points. So you can see right here I selected this point and this point. This is where the mouse comes in handy, because it just might be harder to select things like that if you're not on a mouse. Next I guess I can show you if you had a mouse, you would just use the scroll wheel, but I can, like I said before, if I click and drag with the scroll wheel, I'm going to start rotating the object. I can make it go upside down. Something to note here is that the top of the object, that's going to be a lighter gray than the bottom of the object. So we can see that difference here. Another thing is zooming in, zooming out. So like I said before, if you have a mouse, you're going to want to use the scroll wheel to zoom in and zoom out. And it does depend on wherever your mouse is located. So again, I can't do that now because I have my microphone connected to my USB, and I only have one working USB right now, so I don't really have room to put in a mouse. But if I put my cursor right here inside this little hole and I zoom in with my mouse, it's gonna zoom in. Well, that wasn't good. Okay, it's gonna zoom in like that. It's gonna zoom in focused on the hole. And if I put my mouse here and then I zoom in, it's gonna zoom in over here. And the way I can zoom in, if you're lucky enough to have a touchscreen on your laptop, is just do what you would typically do with your iPhone or your laptop. Just do the 2 fingers and then move them apart to zoom in. Okay, so we can see that we have axes down here, and you can see that as I move the shape, those axes move. So if we want to get into isometric view, I can press Control 7, like I said before, and now we can see that you have a very typical coordinate system. You have Y, X, Z, and they look like this. So this is isometric view. If I want to get to the view of a face, what I can do is I can turn this around a little bit. So let's say I want to see this face, but I want to see it like head on. I can press Control 8, and now I can just act like I'm looking directly at it instead of at an angle. If I want to do the same with the other face, I can kind of turn until I kind of get to it, and if I want it straightened out, I can press Control 8 again. And now we're directly looking at that face, and I'll just do it one more time on the top. So I'm kind of almost completely looking at the top of it head on, but I want it completely straight, so I'm going to press Control 8, and now it adjusts it to look like that. And if I want to get back into isometric view, I'm going to press Control 7. Control 7 is super important because it's really a great view to see how things are 3D, how things are cut out, and this is like the automatic go-to. It's like the home button of SolidWorks. This is what you want to get to automatically every time when you're making adjustments and things like that. So let's say, like I said before, I lose my shape, I'm zooming in and out too much, I've kind of just lost it now. I can press Control 7 and get right back to it. Keep in mind that if I lose my shape and I press Control 8, all it's going to do is move that axis on the bottom. You're not going to get back to your shape. You have to press Control 7 to get back to it. Okay, so I feel like I've gone through everything that I could with this part here. So what I'm going to do is I'm going to go to the top part. I'm going to click File and then New. So this screen is also the screen you're going to see when you open SolidWorks for the first time. What I want to do is I want to click on Part. We're really not going to use assembly or drawing. You're only going to really use these if you're in a subteam or if you're in CAD for mechanical engineering or doing something else on SolidWorks. All we're going to need for L1 is the part. So assembly, just to go through what that is really quickly, assembly basically just puts a bunch of parts together. So, I mean, if we don't have a part created, we can't assemble anything, right? So just make sure you hit part. Okay, so now I'm on a blank SolidWorks page. Let's just go through those planes. So here's the top plane right here. And as I select it, it's going to stay in place. But if I click another one, it's going to go out of it. So this is the front plane, like I said before, and this is the right plane. So I can show all of these just so you can really see how they look. So these are all my planes put together. I guess I could have showed you this picture in the PowerPoint, but I think this would have been a little bit more confusing if you've never seen planes in CAD before. So that's why I did the box thing first. I'm just going to hide all these again. Hide, hide, hide. So basically in SolidWorks we're going to use 2 tabs here. So we have the Features tab. This is what you're going to use to extrude things and do more things with their 3D shapes. And then you have the Sketch tab. This is where you're really going to do all of your 2D things, so like drawing the lines, drawing the shapes. So just make sure that you're always paying attention to whether I'm using the Sketch tab or the Features tab. I can't tell you how many times I tried to search for Extrude in the Sketch tab just because I didn't go to Features. So make sure you're paying attention to that part. So I'm just going to show you a couple of lines on SolidWorks. I'm going to click pretty much any plane, it doesn't really matter. I can click the front plane, and then make sure you're in Sketch and click Sketch. Okay, so before I start sketching, I honestly probably noticed this way too late. You should probably notice it as soon as you make your new part. Pay attention to the units down here in this bottom corner. It says IPS, that stands for inch pound second. Our fins are in inches if you remember from the open rocket videos, so you need to make sure this is in IPS. I believe if you have SolidWorks downloaded, it should automatically be on IPS, but if you're using someone else's computer, if someone else in the computer lab has played with the settings, it might be automatically set to MMGS or CGS, especially because MMGS is what we use in the CAD class, CAD for Mechanical Engineering. So you always want to make sure that for L1 at least, you're in IPS. Keep in mind that sometimes if you're in MMGS by accident and you sketch in the wrong units, that can really mess with things. I can't tell you how many times people have asked in lecture, like, oh no, I just did the entire assignment in the wrong units, and then they're trying to figure out how to fix everything, and it's just this whole entire mess. So this is a big deal. You need to change your units in the bottom. And honestly, I might just put reminders at every single timestamp, just to remind people, because I really don't want that to be screwed up, because then if we cut them out and they're in the wrong units, then we've just wasted some material. So, alright, now that that's established, make sure that's checked. I started sketching, so I'm already in the sketch. We can see that there's the sketch created here. This little minus sign I'll go through later, but I'm gonna go to this line tool. There's other tools like circle, spline, rectangle, arc, ellipse, like all of these things. We're really just gonna be using the line tool. We're not even gonna use the rectangle tool because like our fins aren't shaped like a rectangle. So honestly, I think the only one we're gonna really be using for L1 is just the line tool. It's easy enough. So I'm gonna hit line. And then I come up with a menu on the side that says insert line. There's a check mark and an X mark. You'll notice that you're in the line tool because there's a pencil and a line coming off of it on my cursor. Something to keep in mind is that whenever you're sketching, you should really be sketching on the origin as your first line. So just remember that you're going to click down. And now this line is just kind of, I can put it anywhere I want. I want you to notice that when I go like this, there's a little yellow relation point, and it's not green yet because I haven't clicked down yet, right? I can still move this. So basically what SolidWorks is trying to tell you is if I choose to click right here, right now, it's going to make a vertical line. That's what the yellow relation means. And I can do the same thing with horizontal. This is a horizontal line. If I click down, it's going to make a horizontal line. So when you're sketching your fins, try to get it like this the first time, just so it can be like a really easy, you know, like really simple. I don't have to establish any relations because they're already established for me because I chose to go with the suggestion of the yellow relation. So you'll notice that as I'm drawing, when you draw a line, it's not going to automatically take you out of the line tool. It's going to keep going as I make more clicks. But let's say like, okay, I've had enough lines here. I'm done with this tool. I'm just going to hit escape on my laptop, and then it will get me out of the line tool. Just like with Google Docs or with your laptop in general, Control Z is going to undo your lines. Or you can just select a line with your pointer and hit delete. So I'm just going to undo all of these just to show you some relations. So I'm going to hit the line tool again. I'm going to start at the middle. And let's say this time I didn't make my line completely straight. I didn't pay attention to this vertical relation and I just put it here. Well, that's not a vertical line. It's not lined up with the axes here. So, but what if I wanted to make it vertical? Well, I'm going to click on this line. And just this should be obvious from how I did before, but like if you're hovering over a line, it's going to turn orange, and if you click it, it's going to turn light blue instead of dark blue. Now that I've selected the line, I can go to add relations. I can make it vertical, and now that relation is back. And even if I put it here, even if I put the line here, I can also make it horizontal. There's another option here called fix. For L1 and for CAD for mechanical engineering, I suggest that you never ever use this. Literally, our CAD teacher told us, like, you will probably never have to use fix, it just messes things up. For your subteam, that might be a different story, but just don't mess with this. Don't use it for now. So I'm just gonna make it vertical. Actually, maybe I'll keep it like this so we can show some more examples. So like I said before in the Smart Dimensions section on the PowerPoint, this line is blue, which means if I click it and I move around with it, I can adjust it. It's not fixed. I can make it longer, I can make it shorter, right? That's because it's not Smart Dimension. It can do, SolidWorks hasn't been told it needs to be a certain length. SolidWorks hasn't been told that the relation needs to be vertical. But if I make it vertical, now I can still adjust the length. That's why the line is still, that's why it's still underdefined, right? That's why this point is blue at the top. But the relation is established, so it's never going to stop being vertical because I established that relation. So I'm going to undo this again, and it's going to, okay. If you wanted to ever delete a relation, you'll see in under existing relations, I can just select it and press delete. And now this line can go back to being whatever. So I'm going to actually draw another line. I'm going to use the line tool. And I'm going to draw this line just in a random place. I'm just going to put it like that. And I'm going to escape to get out of the tool. And what I'm going to do is I'm going to select this line and then control click the other one. Control click the other one. And I can make these two lines parallel. So you'll notice that your menu for relation expands here because now you have two lines now you have two lines instead of one. So you're going to hit parallel. And now these two lines are automatically parallel. So we can see that basically what the 2 means is that this is the second, well, I don't know if it's the second parallel relation, but you can match up, if you have multiple parallel lines, you can match up this parallel relation with a 2 to the other parallel relation with a 2. That's what those numbers are there for. So if I click out of this, notice that these lines are still blue, so that means that I can still drag them apart from each other. But I'm dragging up and down right now, and I can't move that up and down. That's because I've established the parallel relation. And notice that I can still drag the point if I want to. That's because I haven't smart dimensioned it. I've only established the parallel relation. Okay, so these are parallel now, but I can actually just delete that relation if I wanted to, and move these back so that they're obviously not anything to each other, right? And then I can click these again, and I can make them perpendicular. So this might not look perpendicular now, but if I were to extend the line, if I were to extend this line, then now they're perpendicular, right? So perpendicular doesn't necessarily mean that they have to form this right angle here. It just has to mean that this is perpendicular. Okay, so you might have noticed before that I tried to move this point and I couldn't, and I was a little confused. It says cannot drag, this selected item is fixed. So the reason why it's fixed is because there is actually a coincident relation here. So we can remember the symbol means coincident, and remember coincident means that you're forcing a point to be on a certain line, or you're forcing another line to be on that line. So the reason why this is actually good is because this guarantees that this line is on the origin. So remember I said before that you have to start at the origin. The reason why I know this is correct, I know this is directly on the origin and not like a little bit away from it or anything like that, if I zoom in really far, is because I have the coincident relation there. SolidWorks is telling me, yep, don't worry, that line is on the origin, don't worry about it. So if I were to take away that relation, now I can move that point, and now I have a problem because it should be on the origin to start out with at all times. So that's why that coincident relation is good to have. It just guarantees that it's going to be on that line. But if you want an example, I can just take this point and then select this line and then tell SolidWorks these are coincident. And now this line is not going to come off of that other line no matter what. So no matter where I move it, I can move it side to side, up and down, diagonally. It's not going to come off the line. Even here, it looks like it's not on the line now, but if I were to extend this line, you can see that it's always going to be there. Even if I move it like this, it's always going to be on the line now. That's because I established the coincident relation. Okay, so I'm gonna just delete all of this. So delete. What I'm gonna do now is I'm just gonna show you an extrude on a simple square. So I'm just gonna, so notice I have the little yellow relation showing coincident. That's what I want. I want my line to start on the origin. So I'm gonna click here. Okay, I'm just gonna make sure that I'm drawing a square or a rectangle, honestly. So that's how I know that it's going to be a horizontal line. Like I said before, I have the little yellow relation, and I'm just going to keep doing that. Notice how I have dotted lines here showing me that if I stop my line here, it'll be another horizontal line directly to the origin. So I'm going to stop there like SolidWorks is telling me. And now you can see that if I put another horizontal line, I'm going to hit the origin as it was saying before. So this is what I was talking about before about the differences between SolidWorks 2020 and 2018. I think that if you close this shape, it doesn't fill it in into the 2018 version. So this filled in part, if you don't have it on your screen, I might be completely wrong about that, but that's just because I have the newer version. So I'm going to press the check mark. I'm done sketching and everything, so okay. So now let's go over some smart dimensions. So I just kind of blindly sketched a square. This doesn't look like a square completely. If I zoom in, this looks a little bit longer than this. And that's okay with SolidWorks. You can just kind of roughly sketch something and not have to worry about how long the line should be until after. That's what Smart Dimension is there for. So I'm going to hit Control 8 just to get this a little bit more straight and centered. Okay, whatever. Okay, so I'm going to hit check, and then I'm going to hit Smart Dimension. Okay, so what I'm going to do to Smart Dimension something is if I want this line like Smart Dimension, I'm just going to click it. So this line before was 1.92. I'm going to click again, and now it lets me adjust this line. So I guess I'll just adjust it to 2. And then I will either hit enter or I'll hit the check mark. I'm just going to hit enter. Okay, so now that's established. And the next thing I have to do is I'd have to smart dimension the top part here, because SolidWorks is going to assume that this part over here is the same length as this side. But if I just exit out of smart dimension just temporarily to show you something. So why is this line blue but the rest of them are black? Well, that's because I didn't define the width of the square yet, right? So if I didn't define the width of the square yet, that means I can just kind of pull it out to be whatever I want. So that's not good. I don't want that, right? So just to show you even more that it doesn't really matter what your rough sketch looks like, I'm going to smart dimension the bottom. And I'm going to, this is 4.28 before, and then I'll click again, and I will make this 2. And as we can see, it didn't really matter what our width was before, because we're going to smart dimension it anyway to 2. And then I'm going to hit check. And we can see everything is fully defined now. There's no blue lines here. And you'll notice that that little minus that was there before, if you noticed it, is not there anymore. That's because the sketch is fully defined. So if you have a traffic light and there's no minus here, then you're good. You're fully defined. And now you can extrude things. So make sure that you exit out of the sketch when you're done, and you'll see that the traffic light has gone away because you're not editing it anymore, and now I have my perfect square. So before we move on to extruding, let's go to sketch again to open that sketch up again. So what I want to show you before is what I was saying about overdefining. So overdefining basically is like being redundant with your dimensions. So sometimes you might think, well, being redundant might be a good thing because then you can really get your point across. But for SolidWorks, it's really not a good thing. If you're too redundant with your dimensions and things like that, then SolidWorks is actually going to get really, really confused. So I'm going to show you that right now. I'm going to go to Smart Dimension, and I'm going to Smart Dimension this line. So SolidWorks already knows that if this line is 2, and these are horizontal and vertical relations, and this line has to be 2 as well. But if I tell SolidWorks I need this line to be 2, even though it already knows that, watch what happens. So as we can see, when I click down, SolidWorks already knows it's 2, but what if I tell it again that it's 2? It's going to say make dimension driven. I'm telling you, you should not do this unless you're in desperate times. So the thing about making a dimension driven is that SolidWorks is going to automatically correct things for you. And just personally, I can't keep track sometimes of what exactly it's done, especially when the wording gets really confusing. So I would only make dimensions driven if you have like 5 minutes left of your CAD exam. So try to avoid this and try to find what is overdefined in your sketch before just desperate move, clicking OK, make it driven, because it can just cause a lot of problems. But basically, you've been redundant to SolidWorks. It already knows that that other side is 2, and now it's confusing itself. So you don't want to do this. You can see that it's yellow, right? And if I click the X or the X, it's gonna go away, right? But if I don't click the X, if I say leave this dimension driving, and I press OK, I'm not going to be able to do anything with this now because I get a ton of error messages. I get something on the bottom that says overdefined, the sketch is overdefined, click to resolve a conflict. I get a yellow triangle with an exclamation point in there, and that's like never good. And then I have things on here that say item conflicts. If you had red things, that's especially bad because now SolidWorks can't figure out what to do at all. This just means that like there's a little bit of a problem here, but this means I can't do anything. So let's undo all of that. I guess I can't really figure out how to like have it shown here, but if you have something that's if you have something that's overdefined, and then you exit the sketch, I think it's gonna show like an like the symbol, the yellow triangle with the exclamation point here. So basically, the way that you know that your sketch is completely good and correct and good to go is if you exit the sketch and you just see this shape here with no minus and no triangle or anything like that. So let's finally get to extruding. I'm going to go to features and I'm going to go to extrude boss base. But before doing that, I always like to get an isometric view. So, okay, extrude boss base. Yes, okay, so I've hit extrude, and now it's saying select a plane or an existing sketch. So you could do it like this. You could just like click this sketch, and then it will start the extruding process for you. But the better way to do it probably is to click the sketch itself, have it highlighted. The reason we should do that is just so we're not accidentally selecting things that shouldn't be selected. Just have the sketch selected itself and then press extrude boss base. Okay, so this is where you're gonna start. Oh, sometimes this isn't open. Sometimes direction 1 isn't open. Just make sure you open that. This parameter here, it changes how much you extrude your shape out, so I can go up and down with this. Keep in mind this arrow, I can also just drag it in and out to extrude things. And you don't really need it for this. I'm just actually going to turn here. You don't really need it for this case, but like you can also reverse the direction of your extrude. You can extrude it down instead, but I would just leave it. You don't really need to do anything with that. That was just a fun fact there. So let's say I want to make the depth 2 so it's a perfect cube, and then I just hit enter and it shows you the preview in yellow, and if we're good with that we can press the check. Okay, so actually this is the bottom of my shape, and I know that because this part is darker, so I can just rotate it. I don't know. Okay, whatever. So like I said before, I think I sketched on the top plane. Not completely. Oh wait, no, I sketched on the front plane. So that's where I sketched here. I can tell that because there's the blue dotted lines here. So that's how you extrude something. It doesn't really matter what plane you sketch on. The only time it really matters is if you're told to sketch on a certain plane in class, or if you're 3D printing something, because like if I were 3D printing something and I drew something like this, like maybe I drew like a little statue here or something like that. Notice if I go to isometric view and if I drew the bottom of the statue to be like on the front plane here, then it's gonna print out sideways, and that's just gonna mess with things. So when you're doing your fin, it's not gonna matter. But if you're 3D printing things, or if you're in class, the plane is actually important, but not always. Not for this case. Hey everyone, I totally didn't realize that this video was gonna be 45 minutes long. I only realized that while starting to edit, so I'm going to end this video here and keep it as a basics of SolidWorks video, and the next video will go over how to sketch your fins. So that's it for this video, and feel free to move on to the next one.
Subscribe to our channel to keep up with all our latest content and launches. For more of Rutgers RPL, check out our social media links, as well as our website at www.rutgersrpl.com. Join us today.